A particle P is projected vertically upwards from a point on the ground with speed 17, and then you have a Q which is also projected vertically upwards from the same point with speed 7. Particle Q is projected t seconds later than particle P, given that the particles reach the ground at the same instant. I have to find the value of the t. So let's see, I have particle P, I have particle Q here. Both are projected upwards and they are having our initial speed, which is 17 and 7. So what will be your acceleration when it is moving upward? For both it is negative 10. So can I find what is the time taken to go upward? It means at maximum height, what will be the time? Okay, you need to figure out the time. So what happens at maximum height? You know your speed is going to be 0. So what I can do V is equal to U plus 80 or 17 divided by negative 10. That's the fastest way you can do it. Okay, so I have 0 here, 17 minus 10t. Rearranging will give you 1.7. So this is 1.7 second. Similarly, you know that this one will give you 0.7 second. So what is the meaning? So it means this is going upward. Let's say this is the maximum height it is reaching and the time taken is 1.7. Whereas this one also reaching its maximum height because it's being projected with smaller speed 7. So it might not travel as much as the P. So the time here is 0.7. So what is the total time taken to complete the journey? Can you figure it out? So I'm going to write here total time to complete the journey means to go up and then come back to the ground level. Both must reach the ground. And then there is a tips here which says at the same instant. So to go up and come down, I will do 2 times by 1.7, which is 3.4 second. For the other one, you are going to get 1.4 because they must reach the ground at the same instant and Q is being projected later. See, I know that I am getting 3.4 second for my P. So it goes up and then it is coming down. And the total time taken is 3.4. Whereas this whole journey, it's only 1.4. But they must hit the ground exactly at the same time. So this is the longer time. So what will you do? You will plus 2 to this so that it is equivalent to 3.4 second as per the particle P. So can you guess what is the value of your t now? So t is equal to 2 seconds. The second part of the question wants us to do what? Now, at a certain instant when both P and Q are in motion, P is 5 meters higher than Q. So if this is the height of the Q from the ground, P is somewhere up here. And then you know P is 5 meters higher. So this whole part is 5. Correct? So this is the journey of my Q. So I'm going to find the distance traveled by the Q. And then I'm going to find the distance traveled by P. Okay? And I want to equate them because I want to know at what instant this exactly happens. So what will you do? So I'm going to do for as P first. I'm going to use ut plus half at squared. Initial speed is 17. The time we are taking is t. Okay. One more consideration. If the time for this is written as t, what will be the time for the Q's journey? What will you do for the Q's journey? Will you do t plus 2 or will you do t minus 2? It's supposed to be t minus 2. Okay, how do you consider this t value here? Maybe you can see it as how long the particle P has been on the air. It means it is moving in the air, like it's going up and coming down. For how long? And that time I'm going to regard it as t. Or you can say the 3.4 is exactly the t. Right? So for the Q, you will logically write t minus 2. Because My t is 3.4. So 3.4 minus 2, I do get the 1.4. Who is longer in the air? Definitely the p. So for the q, you need to deduct. Okay, for those who can't get it, okay, let me write here. This is p and q. I'm putting this as t and this as t minus 2. How long p has been in the air? Let's say I'm putting it as 10. What will be the time taken for your q? Isn't it 8? So you know that this is p is longer in the air compared to your q. What is another way of writing? Some student might say that, why don't I let the time taken by the q to be t? This is also applicable. If you let the time taken by the q as t, then for the p you will do t plus 2. So you can do either case 1 or you can do as case 2. Whichever way you are doing, by logic, the time taken by the p must be longer than the q. You can even try with this. See, if I take the time here as 10, I will get 12. So this is, for the q it is 10. So 12 is greater than the 10. Can you see the logic? Okay, using that, continuing with that, let's do the second part. Okay, in our case, what are we doing? I am doing this scenario. I'm doing the scenario 1. The time taken by p is t. The time taken by the q is t minus 2. So this is just a t for me now. Plus half minus 10 t squared. So I think you will simplify. Minus 5 t squared. Done. Okay, what is for SQ? ut. Your u is 7. What is your t? T minus 2 minus 5 t minus 2 square. Can I take as p equal to SQ? You can't, because p is 5 meter higher than q. So we will write an expression like this. And solving this, we will end up with, let's see, I write 7t minus 14, 5t squared. An expansion here will give me minus 4t. So plus 20t minus 20. This cancels away with this. I have 27 minus 17, I get 10t. This one is 34 minus 5, it's 29. So your t is 2.5 seconds. So let's have some intuition about my t value. See, this t is referring to your p or q, both. But I know I let, just now what did I do? I let the time taken by the p to be the t. So I will directly go to the image of the p here to inspect. If the time taken to go up, it's 1.4 second. So 2.9 is on the way downward, backward like that. So my v value will definitely be negative. Okay. So what will be the time for my q? It is t minus 2, correct? So you will do 2.9 minus 2, which is equal to 0.9. So let's check what is happening to particle q at t 0.9. So it is also in the reverse journey, because to reach until its maximum height, it's just 0.7. You okay? So let's find the v of my p. Why I have to do this? Because the question actually asking me to do that. Find the magnitude and direction of the velocity of each particle at this instant. So v of p is 17 minus 10, 2.9, which will give you minus 12 meter per second. You write there the opposite direction. It means it is moving towards the ground. And then what is v of your q? 7 minus 10 times by 0.9. So 7 minus 9 is minus 2 meter per second.